Hello, my name is Alex, and in this project, uh, I develop a machine learning model to predict the electrical energy output of a combined cycle power plant. The goal of the project is to use environmental sensor data to predict the net hourly electrical energy output of the plant. The dataset contains thousands of observations collected from sensors that measure environmental conditions affecting the plant's operation. Using this data, I built and evaluated machine learning models to determine which model best predicts the plant's power output. The first step in the modeling process is identifying the type of machine learning problem. In this case, the task is a supervised learning regression problem because the variable we want to predict is continuous. The dataset includes four environmental variables used as features in the model: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. The target variable is PE, which represents the net hourly electrical energy output of the power plant measured in megawatts. Because the target is a continuous numeric value, regression models are appropriate for predicting it. The dataset contains approximately 9,568 observations, each representing hourly measurements from the power plant. Each observation includes the four environmental variables along with the corresponding power output value. To build and evaluate the models, the data is conceptually divided into two parts. The training set is used to build the predictive models, and the test set is used to evaluate the final performance of the selected model. For this project, the regression models were implemented using Excel. The first model used in this project is a multiple linear regression model. This model predicts the power output using all four environmental variables: temperature, exhaust vacuum, ambient pressure, and relative humidity. The model estimates how each of these variables contributes to predicting the energy output of the plant. In the spreadsheet, predicting power output values are calculated for each observation. The prediction error is calculated by subtracting the predicted value from the actual value, and the squared error is then computed for each observation. These calculations allow us to evaluate the performance of the model. The second model used for comparison is a simple linear regression model. This model only uses one predictor variable, temperature. The purpose of building this simpler model is to compare it with the more comprehensive multiple regression model. Like the first model, predicted values, prediction errors, and squared errors are calculated in the spreadsheet. This allows both models to be evaluated using the same performance metric. To compare the models, we use root mean square error, or RMSE. RMSE measures the average magnitude of the prediction errors between the predicted values and the actual values. A lower RMSE indicates that the model's predictions are closer to the true values. After calculating the RMSE for both models, we compare their performance. The result shows that the multiple linear regression model has a lower RMSE than the simple linear regression model, which means it produces more accurate predictions. From these results, we can interpret how environmental variables affect power generation. Temperature alone cannot fully explain variations in the power plant's output. However, when additional variables such as pressure, humidity, and exhaust vacuum are included, the model is able to capture more of the relationships affecting power generation. This demonstrates that using multiple relevant features improves the predictive accuracy of the model. Here we can see the Excel implementation of the regression models using this project. On the left side of the spreadsheet is the dataset, along with the predicted power output values, the prediction errors, and the squared errors used to compute the RMSE evaluation metric. On the right side, we can see the regression analysis output produced by Excel, including the regression statistics, ANOVA table, and the coefficients for each environmental value used in the models. This demonstrates how the regression models were built and evaluated using the dataset. In conclusion, this project demonstrates the machine learning model process. First, we define the problem as a regression prediction task. Next, we build two regression models a simple linear regression model using only temperature, and a multiple linear regression model using all environmental variables. We then evaluate the models using RMSE and compare their predictive performance. The results show that the multiple linear regression model provides more accurate predictions because it incorporates multiple environmental factors that influence power generation. Thank you for watching.